Hi to everyone. Let us go for the series of orthogonal transformation of a real symmetric matrix. Here in this topic we are going to see the nature of quadratic form. So in the previous series we have seen how the quadratic form is converted to a matrix and matrix is converted to a quadratic equation. So here with the conversion of quadratic into a matrix form, the next step we use to find the eigenvalues and eigenvectors. So from the extension of eigenvalue, eigenvector and orthogonal transformations, we are going to find the nature of quadratic form. So the nature of quadratic form is calculated with the by two types, that is by principal minus and the eigenvalues. So before going to the topic of nature, so let us have a small recap about what is quadratic form. So in the quadratic form equation, it may have multiple variables instead of single variable. So which involved in the polynomial expressions, and each term is a product of two variables. All terms have the same degree. So we can simply call that expression as an homogeneous polynomial equation of degree 2. So if it is an quadratic form of having a degree 2, then we can find the nature of quadratic form by principal minus as well as eigenvalues. So how to classify a quadratic form based on eigenvalues? So we are having 5 types of nature. So one is positive definite, next negative definite, positive semi-definite, positive negative semi-definite and indefinite. So if all the eigenvalues lambda are greater than 0, then we can say it is a positive definite. If one of the eigenvalue is 0 and the other two are positive, then it comes under positive semi-definite. If all the eigenvalues are negative, then it comes under negative definite. If one of the eigenvalue is 0 and other two are negative, then we say negative semi-definite. If it is in the combination of both positive and negative eigenvalue, then it comes under an indefinite in its nature. Now let us go for nature of quadratic form by principal minus. So the principal minus is calculated by taking a determinant for first element, that is a11, which is named as an d1, and 4 elements a11, a12, a21, a22. When you are taking the determinant for these 4 elements is given the name as d2, and d3 is determinant of 9 elements, that is 3 by 3 matrix. So similarly we can find the remaining values also. So when you are considering a 3 by 3 matrix, we get d1, d2 and d3. If all the 3 are positive values in expanding the determinant, when you are getting all the values are positive, then it is a positive definite. If alternatives are negative and positive, then it comes under a negative definite. If one of the value is 0, the other two are positive, then it comes under a positive semi-definite. Similarly, negative semi-definite. If there is a combination of both positive and negative, then it comes under an indefinite in its nature. So now let us discuss with its problem on nature of quadratic form by principal minus. So let us consider an equation 12x1 square plus 3x2 square plus 12x3 square plus 2x1x2. So here the given equation consists of an 3 variables x1, x2 and x3 with an degree of 2. So when you are converting this quadratic to a matrix form, we get a 3 by 3 matrix. So we have to take the coefficient of square terms 12, 3 and 12 as a diagonal elements. The remaining the elements are based on the coefficient of x1, x2, x2, x3 and x3, x1. So here we are given with the coefficient of x1, x2 as 2. It is shared by 2 places, so we have to divide by 2. So we are getting a matrix of the form 3 by 3 matrix 12, 1, 0, 1, 3, 0, 0, 0, 12. So with this matrix A, we are going to find the nature of quadratic form by using principal minus. So for that we are considering d1, that is the element a11, that is 12, which is greater than 0. d2 we are considering 12, 1, 1, 3. So when you are expanding this determinant, we get an answer as 35 which is greater than 0. Now D3. So that is determinant of entire matrix 3 by 3 matrix. So that we get an answer as 420 which is greater than 0. Since all the values D1, D2 and D3 are greater than 0, we get positive in its nature. So when one of the eigenvalue is 0 and the other two were positive, then it comes in a positive semi-definite. Likewise, we can find the other nature based on the D1, D2, D3. Now, let us determine the nature of quadratic form using eigenvalues. As we discussed earlier, the positive definite is lambda greater than 0. All the lambda value should be greater than 0. Negative definite is all the lambda value is less than 0. Positive semi-definite is all the lambda value greater than 0 and at least one lambda value is 0. And negative semi-definite is all lambda value less than or equal to 0 and one lambda value is 0. Indefinite is mixing of positive and negative in its nature. So now let us calculate the problem on nature of quadratic form using eigenvalues. So we are given with a quadratic equation 2x1 square plus 2x2 square plus 2x1 x2. So here we are given with two variables x1 and x2. So we able to construct only a 2 by 2 matrix. So 2, 1, 1, 2. So when you are finding an eigenvalues for the given matrix, we have to go for characteristic equation determinant a minus lambda I equal to 0. So when you are expanding this one, we get an eigenvalue of lambda 1 equal to 1 and lambda 2 equal to 3. Since both eigenvalues are positive, we get positive in its nature. So if one of the eigenvalue is 0 and other is positive, then it will result in positive semi-definite. Likewise, in a negative definite is if both eigenvalues are negative, then we can say it as a negative in its nature. If there is a combination of both positive and negative, we can say it is a negative, indefinite in its nature. So as a conclusion of this problem, we can say since lambda 1 and lambda 2 are greater than 0, the quadratic form is in a positive in its nature. Thank you.